All right, today we are talking about traversing arrays. And if we remember traversing strings, this is going to be a very similar topic. So, brief recap of what arrays are. Arrays are a type of object in Java that allow us to store multiple values of the same type. So we can have a whole bunch of the same kind of thing stored in one variable rather than having to have multiple variables. Once we create them, they are fixed in size. We cannot add or subtract elements from the quantity we're able to hold. If I want to initialize an array full of default values, usually this is going to be 0 or nothing or null or anything that represents there's no value here. We're going to have our type of value that we want to store. Those square brackets are going to indicate this is an array variable. We've got our name, we've got the new keyword, that type again, and then how many elements we want to be in this array. If we want to create an array full of values that we choose, if we want to initialize it with a list of values, left side of the equal is going to be the same. This is us declaring that array variable, and it's going to equal some list of elements. They're going to be separated by commas and placed within those curly brackets. So there are two different ways for creating an array. Both of them work equally well. It just depends on how you want it to be initialized. We are able to access individual values, also known as elements, out of an array by referencing their indices. So if I have my int array called scores, and it has these 5 values in it, if I print scores at index 0, we're going to get 80. Since arrays can have lots and lots and lots of elements, we need to have a systematic way to access every single one, because it's not very efficient to write scores 0, then scores 1, then scores 2, etc. We need a better way to accomplish this. So, systematically accessing every element in an array is called traversing that array. And we can traverse arrays in almost the exact same way as we can traverse strings. Usually we're going to want to use a for loop because we know how many elements there are in an array before we start our loop. And this is often even easier with arrays than with strings because there's no way for our array to change in size or for things to go weird and make our loops become infinite. But we're going to use loops to look at every single element. So if I have my int array called scores and I have 5 elements in it, I can do a for int I equals 0, I less than scores dot length, I plus plus, very, very similar to our string loop. We are just accessing the length variable rather than calling the length method because that is how arrays work. And then inside of our loop, we don't even need to call any methods to access the current value. Remember with strings, we needed to call the substring or char at methods to get the current character. Here, we can just access our array at the index I, at the current index, and that will tell us the element at that place. So no matter how long the scores array is, no matter how long it's initialized to be, this loop will access and print out every single element in that array on its own line. And remember, just like when we traversed strings, we want to loop as long as our iterator, as long as that variable I, is less than the length of the array. We do not want to say less than or equal to because there is no index 5 in this array. So scores.length is 1, 2, 3, 4, 5 elements. I have 5 things in this array, but my largest index is 4 because we start counting at 0. 0, 1, 2, 3, 4. So if I try to access at index 5, we're going to hit an array index out of bounds exception, which we once again want to avoid. So We want to always have that be a less than, not a less than or equal to. So let's do an example. Let's say we want to build a method that will take two different parameters. First parameter is an array of integers. Second parameter is a target integer. And this method should return the index where the target integer can be found, or -1 if we can't find it. So what steps are we going to need to take to accomplish this?
Method signature.
Method signature, absolutely correct. What are we going to do after that? Are we going to need to loop over the array? Probably. I'm going to check if the thing we're looking at is the thing we're looking for. And if it is, then we will return the current index. So what is our signature going to look like? What type of value are we going to return here? Obviously, we're going to have a public method. What type are we going to return? If we're going to be returning an index, what type is that going to be?
An integer.
Absolutely correct. So we're going to return an int. Let's just call this find index or something. And we are going to take two parameters. Our first parameter is an int array called r, and our second parameter is an int called target. Boom. So we have our signature created. We're going to loop over our array, just like we have been talking about throughout this lesson. So we're going to have that for int I equals 0. I is less than the length of my R array. We're going to increase I by 1 each time. If I want to check if my current value matches the target value, what is our if statement going to look like? I'm going to check if. So we want to check if target matches something, right? Do we need to call an equals method? Can we just use the equals comparison? What do we want to do here?
I believe it's just double equal.
It's just going to be double equal because we are working with primitive value types here because we're working with integers. So we are able to just use that double equals because we're not going to be comparing any references. So if our target equals our array at the current index, if target is equal to array at index I, and it doesn't matter the order that you have those around your equals, then what should we return? If the thing we are looking for is at our current index, what do we want to return?
The end.
The index, which is stored in the variable. Correct. We're going to return I. So after we've finished our for loop, if we never returned I, if we never found what we were looking for, then we are going to return -1. So we return -1 saying, hey, that value was not in that array. So if I actually do an example, let's say my scores is that same array we've been looking at, and my target is 91. I'm going to make an integer called ind equaling the return value from find index when I pass scores and target, scores being that list, target being that integer, to it. So R is going to be essentially the exact same thing as scores, and target is 91. So I starts at 0. I is currently less than r.length, which is equal to 5. And we're going to increase I each time. So if array at index I is currently 80, is that equal to our target?
No.
No, it is not. So we are just going to skip that. Do we want to do something when it doesn't match? Do we want to break? Do we want to exit the loop that we didn't find it?
I don't think so, because we're looking for the 91.
Exactly, because if my current thing doesn't match, that doesn't mean that none of the rest of my array is going to match. So we don't need an else on this if at all. This if is exactly like it needs to be. So we didn't see it here. We're going to go up. Now I is going to equal 1. I is still less than 5, so we're going to enter our loop again. Is array at index I, which is now 92, equal to our target?
No.
Still it is not. So we are going to skip our if, jump back up to the top again. Now I is going to equal 2. Now when I equals 2, array at index I equals 91. Is our array at index I equal to our target?
Yeah.
Yes, it is. So we're going to enter our if statement. We're going to return I. So we're going to return that number 2 back here. So our int ind is going to equal the return value from our find index method, which equals 2. So when I print found at this index, it's going to print found at 2. And there we go. Any questions on how traversal of arrays goes? No. Cool. Cool.